All right, so the first problem, we have a definition. It says when the limit of f of x exists as x approaches a, it always equals to f of a. State whether this statement is true or false. So we're still developing the definition of limits and derivatives. So at this point, we only know that the limit exists if both sides approach a point. So right now we say false, the value of the limit of f of x as x approaches a, if it exists, depends on the value of f near a, but it does not depend on the value of f of a. So right now that's what we know. All right, number 2, we have 5 parts, so we're going to evaluate these values. It says use the graph of h in the given figure to find the following value and state whether they exist or do not exist. So I'm going to look at h of 5. So that means I'm going to go to 5 on the x-axis and I'm going to trace it up until it hits the graph. So it goes through that hole and we get the point 8. So h of 5, we get 8. The limit as h approaches 5, so as I trace it from the left, we're still going toward 6. On the right side, when I trace it, it's going towards 6. So the limit of h of 5 is equal to 6. When I find h of 7, so I plug in a 7, and that goes through a hole and there's no other point. So we're going to say h of 7 does not exist because there's no point that we get on that line where x is equal to 7. So wrong box. We're going to say h of 7 is undefined. Limit h of x as as x goes to 7 or x approaches 7. So as I trace it, we get close to that y value of 4. And then if I trace this side, we get close to y value of 4 as well. So the limit is 4, although the value did not exist or was undefined. And then the limit of h of x as x approaches 8. So as we approach 8, getting close to 5, and that is on both sides because we have connected line. So the limit h of x as it approaches 8 is 5.